Hello, Western. So now I want to talk about a different type of physical phenomenon that can also be explained using the superposition principle. And this phenomenon is what happens when you have two wave sources that produce waves with just slightly different frequencies. And this is something that you've heard before. For example, if you've ever strummed a guitar that was out of tune, it creates that wah, wah kind of noise. And this phenomenon is called a beat note. And we can explain a beat note the same way we explain standing waves. We just apply the superposition principle to our mathematical representation of a wave. So here I'm just going to worry about the time dependence, and I'll add these two waves together. Now once again, we'll use the trigonometric identity sine of A plus sine of B is equal to 2 sine of A minus B over 2 times cosine of A plus B over 2. So plugging these formulas into that, we have that y1 plus y2 is equal to 2a sine of 2 pi times the difference in the frequencies over 2 times t, and cosine of the sum of the frequencies over 2. Times t, of course. Now the interesting thing about this is that if f1 and f2 are very, very close, then this number is very small, so we have a very low frequency. And remember, the period is 1 over frequency. So if this number is small, then this whole number here is going to be very big. Okay? So that means it's going to take a very long time for this thing to repeat. So the way we can think about this term right here is it's a slowly varying amplitude. And this second term, because we're adding the two frequencies together, has a very high frequency. And we can think of this term as a high-frequency wave. So we have a high-frequency wave with a very slow changing amplitude. So the resulting disturbance we get looks something like this. So here I've got this blue dashed line that's showing that slowly changing amplitude, and inside here I have this high-frequency wave. So this is what's called a beat note. And it kind of explains now why you get that wah wah noise. Because when the two frequencies are very similar, then the amount of time it takes for this thing to repeat could be very long. It could be, for example, a second or a half a second, and that'll be long enough for you to actually be able to detect that and hear that. Now it's important to understand that these frequencies have to be very close in order for this phenomenon to work. If these two frequencies were very far apart, then this thing would happen very quickly, and you wouldn't be able to hear the changes in the amplitude anymore. So that's where I'd like to leave off with this video. In the next video, we're going to study another wave phenomenon that doesn't have to do with the superposition principle, called the Doppler effect.